Hey everybody, Azure Cosmos DB Live TV. I am your host, Mark Brown. Welcome, episode 59. Joined this week with Chris Joakim. Is it Joakim? I always say this wrong, man. I'm so sorry. I
No,
call you,
good job. Good job. It's Joakim with
you know what? I call
J.
you Joakim because my J's are always H's.
Yeah, my father was from Belgium, so it's more like Joakim, but Joakim is just
Okay. Sorry. Yeah, I will promise I'm going to get this right someday. Anyway, it's great to have you back. You've been on the show before, and it's been a while. It's probably been a year, I guess, since the last time I had you on, I think.
I think so, but it's great to be back, Mark.
I got to go back and look at the archives. There's 15. This is episode 59.
Yes.
So it's a ways back. And folks, hey, that's your invitation to go back and binge watch all 59 episodes of Cosmos DB Live TV. So hey, good to have you here. We're going to talk about something kind of cool that you've called AltGraph. You want to kind of tee this up for us?
Yeah, sure. So it's called that because it is an alternative way to implement a graph solution. Not with a graph database, but with a general purpose Cosmos DB SQL API.
So that's pretty interesting. Like graph databases, the whole key with those, I mean, there's lots of aspects of it, but what's interesting is that they fundamentally kind of materialize relationships for data in a way. Is that would you characterize it that way as well? Or
yeah, so I'll explain that that this design called AltGraph is kind of inspired by a type of a graph database called an RDF database, but it has some other influences as well. So I think it kind of blends the best of all worlds into a pretty practical and performant solution.
Okay, well, I don't want to steal your thunder, and I don't want to confuse my viewers, so I'll stop saying stuff.
Awesome.
I am going to continue asking questions though. So yeah, let's talk about this AltGraph that you've got. I know you got some slides first, and then you're going to show us. You're going to show this thing in action as well a little bit later too.
Yeah. What I'll do is I'll describe, the design, and also point you to the code. So this is a public GitHub repo here. I'm sure that URL will be in the meeting notes or the presentation.
I'll throw the banner up here for folks. So I'll leave it up for a bit too.
Awesome. And so I will do a brief demonstration of it in action. So I'll have a locally running web application. It'll be a Java Spring application, but it will be accessing both Azure Cosmos DB as well as Azure Redis Cache. All right, so let me proceed. How about that?
Yep, sounds good.
All right. So back to answering the question, what exactly is AltGraph? So it's just an alternative graph implementation. So it's built on a certain design, but I also provided a reference implementation, right? So a working implementation of that design. So the design, uses the Cosmos DB SQL API. It uses a RDF database like triples, and I'll talk more about those quite extensively here in this presentation. It leverages caching, right, for speed and to reduce costs, and it does leverage fast in-memory processing. So you can do a traversal like in memory of a data structure at a very high speed versus doing disk I/O against any database.
Yeah,
it's just going to be slower than in-memory processing. So Spring. So that's been a very recurring theme, on this show as well as with my customers. I happen to come from a very long Java background, so but I hadn't really used Spring much before the last year, so I thought I would implement this with Spring and Spring Data. All right, so I'm going to proceed to the next slide.
Sure. Spring's great, by the way. We've had a number of episodes with folks talking about Spring or Spring Data, and I'm guessing you're using our Spring Data SDK.
Yes,
as part of this. Okay.
Yeah, exactly. Which is really quite good. And I've worked with Theo on the engineering team, to understand that. He gave me some really good examples. Yeah, we do have a really nice Spring Data SDK.
I had Kushagra Thapar, who's the engineering lead for that, and he went through an extensive kind of overview of Spring itself and Spring Data and all of these other. I mean, it's really kind of a whole ecosystem of stuff, kind of all kind of mixed together, and then of course went into detail on kind of Spring Data as well. It's really well done. It's quite impressive, actually. So,
yeah,
and it's very popular. I mean, it's that seems to be kind of like the go-to thing for Java development these days.
Yeah.
Is Spring.
Agreed. It's like the dominant, Java web development framework at this point in time.
Yeah.
But yeah, so this is what I'd like to present today. Right. So I want to just talk about the influences. What caused me to do this? Why does AltGraph even exist? I want to talk about perception. So how you think about a problem influences, what you actually implement. I'm going to talk about, about thinking differently. Why does this even exist? I'm going to get into the details of the design, and again, lastly, I'll do a demonstration of AltGraph in action.
Cool.
All right.
Let's
go. All right. So influences. Yeah. So speak of the devils, Mark. Both Mark and Kushagra. They did presentations previously on Cosmos DB Live TV on Spring Data and Spring Boot. I'm actually an owner of this book that Mark Heckler wrote, Spring Boot Up and Running. Quite a good book on Spring. So those are some influences, but mostly, so I'm a Cosmos DB global black belt. I work extensively with customers in the field on everything Cosmos DB and everything Azure as well. And so there's a number of recurring themes regarding use cases I see for Graph. So I work with a number of manufacturing customers. So the concept of a bill of materials graph is something very pertinent to them. And so the reference application that I'll show is a take on a bill of materials app, and I'll discuss that later.
That's cool. I love that use case for Graph. In fact, I've worked with customers in the past, helping them with implementing things like that using a graph. And what's so interesting is it's the nature of Graph itself in building these types of things. Like, you can associate all these things together. So say you have a product and you have all of these different parts that are associated with it. All those can come from different manufacturers in different batches that they themselves include other constituent pieces. And what's cool is you could run a query, like say you have a failure in one of these things, it's way upstream in your supply chain. You could figure out all of the shipped products that thing went into using something like a graph. And it's just fascinating. Like how would you know what product to recall unless you had a graph that actually traced all this stuff together? So it's an awesome use case, I think.
What's interesting too, I mean, so pre and post pandemic, right? So you can imagine like this bill of materials graph that, you and I are talking about. And previously, my customers were more concerned about like the front end of the graph, meaning like the end products, end product was made of components and those were made of, other components, et cetera. And they were more concerned with answering the question, okay, what if I get rid of this product, right? This parent product, what can I do with the components, right? It was from product back. Nowadays, people are more concerned with the supply chain, right? So, given this product that I want to make that contains these 12,002 components, what if I have a supply chain disruption to one of those, right? What's going to be the impact to the products that I make? So so graphs in manufacturing are super useful.
Yeah, and of course, social networks is obviously another key kind of use case for that, and you see that certainly all the time in there. But I love the bill of materials one. I don't know. So
there's all kinds of use cases. Yeah. Something newer is knowledge graphs, and depends who you talk to. Everybody you talk to has a different definition exactly what that is, but essentially it's a graph.
Yeah.
All right. So those are the influences. And all right, so let me talk about perception. And the next two slides are are intended to be somewhat humorous, but it's exactly true, right? So it's my contention that how you visualize a solution, or a problem or a solution, it is ultimately what you're going to implement, right? So if you have a problem, have a business problem, and you draw the solution like this, right? And so obviously you can't see all the details, but this is obviously a relational database entity design, right? Showing the relationships between the various tables. So if your mind is thinking relationally, right, you're going to choose a relational database, to implement this with, right? So the next perception is this, right? So I've actually took this page from our Cosmos DB documentation, and this is kind of obviously a graph, right? So if you were to use, say, Visio, right, or some other design tool, and draw out your business problem, and it kind of looks something like this, where you have vertices and edges, right? So London would be a vertex, this phone would be a vertex, this would be an edge that connects them. So that's in short, graph database speak, vertices and edges. So if you draw the problem like this, right, you're apt to use a graph database, right? Because that's just how you're thinking about the problem, right? So it's my assertion, and it's my strong contention, right, in this presentation and with my customers, that you don't necessarily need a graph database to implement a graph solution.
Yeah, that's interesting. What's interesting there is I think maybe one of the meta takeaways is you kind of fulfill your own destiny, if you will. So if you imagine a thing as you represent it, that's of course what you're going to build, right? So
yeah, exactly.
You want to fulfill your own expectations for what you think the thing is. So in some ways it's self-fulfilling in that way. But
Yeah. So, I was a cloud solution architect at Microsoft for 5 years, and I've been in this role for almost 2 years now. And, we just see this a lot. Customers come maybe without an experience level in Azure, and they kind of come to us with, what they think is the solution. And, often that's correct. They're on the right track. But other times they're just not aware of some of the cloud native things we can do in Azure. And so, if you can kind of work through what are the real business requirements as opposed to what are their initial implementation thoughts, it works out pretty well.
Yeah.
All right. So let me continue. All right. Super busy slide here. So what am I trying to say? So this is kind of a diagram that shows that, or tries to show that, a typical graph solution, right? It's more than just the database, right? A total solution involves, many more services typically, right, in a real world system. So what I'm trying to show here is that, yes, we can certainly have Cosmos DB at the center of the solution. And so these red lines are the direct integrations with Cosmos, by the way. So, if Cosmos is at the center of this graph solution, then you have to think about, how do you ingest data into it? Right. So, we have a couple other PaaS services, Azure Stream Analytics, Azure Event Hubs, high-speed eventing systems. So it's trivial to consume a stream of events and put it into Cosmos DB. Likewise, you're going to want to monitor your database performance, identify inefficient queries, maybe queries that are that need to be optimized. So Cosmos DB integrates beautifully with our Azure Monitor PaaS service. I'm going to talk about this first. So, we have a feature of Cosmos DB is the change feed. So you can optionally observe the stream of changes coming out of the database. So inserts and updates, for like event-driven processing, Cosmos DB combined with functions is just a great solution.
Yep.
Now, more interestingly, regarding Cosmos is the rest of this picture. So it integrates natively and beautifully with a search service we have called Azure Cognitive Search. And as the name implies, it's a search engine, but there's some cognitive or intelligent features about it. Where it can do a vast array of like machine learning type tasks. But this integration is trivial, right? This is all just built natively into the platform. Lastly, I'll mention Synapse Link. So this is kind of, in my mind, this is like a quote unquote killer feature of Cosmos DB. And so it implements the HTAP pattern, hybrid transactional analytic processing. That means that you essentially have a high-speed operational database that is Cosmos, yet the data flows into this data lake-like structure called Synapse Link. And then you can kind of do batch and or machine learning or analytic operations on that data in this data lake like structure. And the nice thing there is that it doesn't consume any Cosmos DB request units or RUs. So you can kind of combine the best of both worlds, use Cosmos for your high-speed operational database, yet at the same time leverage Synapse Link and Synapse for your kind of batch processing and your analytics. So again, the purpose of this slide is to say that you might choose a certain graph database, right, to be the center of your application, but you really need to be aware of this outer ring of adjacent services, because your total system is going to require all of these things.
Yep, that's true. In a cloud environment, all these things basically matter in some way, shape, or form, right? You need someplace to host your app. You need to be able to monitor things, especially monitor in a cloud environment. All these things, are all constituent pieces that matter. Identity or secrets, using Key Vault, hosting your app in a container registry. All those things matter, right? This is a very common looking diagram.
It really is.
A cloud
it really
world,
is.
Exactly.
And so the Cosmos DB is a multimodal database. So we have multiple APIs, but it's the SQL API that AltGraph is built on that offers the best integration. So again, all these red lines is what it offers. The other flavors of Cosmos don't implement all these quote unquote red lines. All right, so let me move on. Yeah, just a brief discussion about databases, types of databases. So, there's relational databases. Everybody understands those, I'm sure. With graph databases, there's kind of like two families of graph databases. There's the RDF, and frankly, I don't recall what RDF stands for right now, but it's essentially a triple store. And that's where you store your data in quote unquote triples. And I'll explain that I think in the next slide. The other family of graph databases is called LPG, and that's where you typically have vertices and edges. And lastly, there's NoSQL, right? So Cosmos DB SQL API, in my mind, it's a general purpose NoSQL database. I'm going to make a little comparison to Python, right? So Python used to be a much maligned programming language, but it's kind of taken over the world, right? It's used for machine learning. It's used for big data processing. It's used for ad hoc scripts. And the reason why Python is so successful is that it's a general purpose programming language. It's easy to use. It's widely understood, low learning curve, super practical. And that's why people use it. And it's kind of my opinion and contention that the Cosmos DB SQL API, is likewise that Swiss Army knife of a database that's good, if not great, for so many use cases.
We'll have to check with Guido Rossum if he agrees that we are the Cosmos is the Python of the database world. So
yeah, exactly. Yeah, I didn't check with him before.
I might get a.
I'm sure he would agree.
Yeah, I'll check my inbox.
Yeah. So why even do this, right? So why even come up with an alternative graph solution? Well, if you want faster execution speed, if you want lower Cosmos DB costs, right? Those are two great uses, great reasons that AltGraph implements. Now, also, there's a lower barrier to entry, right? So the Cosmos DB SQL API, it's just built on simple JSON documents, and you query it with the SQL syntax. So virtually 99% of people in IT, have worked with SQL. So it's widely understood. You don't need to, each graph database has its own peculiar syntax that's, in my opinion, quite a learning curve, right? So you can kind of implement a very high performance database that at the same time is conceptually simple, that allows you to kind of go from zero to implementation, in days rather than months. And of course, in the last slide, I mentioned that just better integration with the rest of Azure. So in short, costs, speed of development are reasons to do this. Sounds like no question there. So
I don't have a question on it. Silence is agreement in my world.
All right.
Sorry.
Yeah. You just nodded your head and said, "Amen, brother."
Amen.
Yeah. All right. So in the next few slides, I'm just going to talk about the design foundations of this thing called, this design called AltGraph. And again, I mentioned the RDF graph databases. That's one of the two branches of graph databases. So that is built on the concept of triples, and a database that is built on triples is called a triple store. So that's some fun knowledge. Now, what exactly is a triple? So a triple is a set of three things. There's a subject, there's a predicate, and an object, right? It's that simple. So for example, Microsoft is a technology company, subject, predicate, object. Cosmos DB has a SDK for C#, subject, predicate, object. So basically, an RDF graph database stores, kind of a huge number of triples, right? So it's in this format. Now, when one navigates or traverses an RDF graph database, what's happening under the hood, under the covers, is these triples are just being read, right? Based on whatever your query is, it's reading this underlying data structure. You're reading through probably tens of thousands of them, to solve that graph query. So it's a super simple concept, triples. So AltGraph borrows this concept, right? There's going to be a document type in Cosmos in the AltGraph design in the SQL API called a triple.
Interesting. I cannot wait to see how you implemented this. This is a great slide, by the way, for kind of explaining it, and almost what I was trying to say earlier, in that a graph materializes the relationship. So here you have relationships between objects, and that is a, or has a, or a works at type of thing. And that's what I see. A graph is materializing those things to disk, if you will, because you have that subject, object, predicate connecting the two.
Yeah. And just kind of connect this RDF model with an LPG model, right? You can think of like Microsoft and technology company as the vertices, and the is a relationship as an edge that connects these two, right? So that's conceptually essentially the same thing, but the implementation stores it as triples.
Yep. All
right. Okay, so the next design foundation is indexing. So, not indexing in a database sense, but indexing as, what one sees at the end of a book. Again, it's just a conceptual model. So just imagine you have a 500 page book on I'm not sure where I got this from, maybe Spring, a 500 page book. But the really interesting part is maybe the last 10 pages of the book, like where the index is. Right. So, that ratio 500 to 10, that's a fairly typical example. So in short, like the triples, right, the set of triples for your graph can be thought of as the index, right, the index in the book. Right. And so you can use the triples to navigate the structure of your graph. Now, looking forward a little bit to the implementations that again, the size of the index of the book, maybe 10 pages, is quite small, right, compared to the book. And it's quite small, so you could potentially store it in memory, right? This 10 pages of the book, so to speak, or the set of triples, you can store in memory of, say, the Java virtual machine, and alternatively, you can cache the index, so you don't have to constantly go back and read the database, right? So this is in general why graph databases are generally slower than other NoSQL databases is that when you traverse the graph, it's apt to touch many nodes in the physical graph. Do disk I/O to read them, whereas this approach uses the concept of an index often in memory.
Interesting. Okay, I'm very intrigued now, and in what you're saying, and this index that you're talking about in here.
Yeah.
I'm all right.
All right.
I'm even more excited now to see how you implemented this. Then.
Yeah, this is great. Yeah, so just a little review of Cosmos DB, and it was born in the cloud. It was never an on-prem database. It scales. It has scalability in its DNA, right? So Cosmos DB has the concept of physical partitions, which is each one of these little boxes here. It's a physical partition. This is like an exploded version of a physical partition. So a physical partition is in fact 4 nodes and not 1. But the point is, as you add more and more data to Cosmos DB, it is apt to reside on, many or, one-to-many physical partitions. Now, what gets inefficient is that if you do a query that doesn't use the partition key, right? So every document has to have a partition key in Cosmos DB, that basically tells Cosmos where to put the data, what physical partition. So, if you're traversing the graph and you have to hop from physical to physical partition and as part of that traversal, that's where it gets slower and that's where it gets expensive. So the nice thing about this design with AltGraph is that the triples can all reside in one physical partition. So for example, if the size of your triples, and I'll show you a sample document sooner or later, if the size of your triples is about 1 kilobyte, then you can store 20 million of them in one's physical partition, right? So this AltGraph design will support a small graph design, but actually something quite larger. If you had more than 20 million triples, then it's okay, to have more. They would just you'd have to change the design a little bit so that the triples would reside in 2 logical partitions or 3, depending on the size of your graph. But the fact that we can land all the triples in the typical case on one physical partition and thus query them efficiently, that really leads to lower cost and faster speeds.
Now, how would you, let's say you had to span partitions here. What is the design change? Are you like salting these things or creating a map, if you will, in another store that then tells you, okay, this range belongs here and this range belongs there?
Yeah. So
or an index on an index, maybe even another approach.
Yeah. So there's several ways to do that. So AltGraph currently, the reference implementation does implement the concept of tenancy, right? So some of my customers, have a multi-tenant application, right?
Mm-hmm.
They have multiple customers all sharing the same database, and so they've their partition key scheme, has essentially like the client ID, vertibar,
Got it.
Customer.
So they're tenant per partition type design is what you're saying.
So a tenant partition, and even if you have a multi-tenant with more than 20 million, you could further partition it by. There's going to be types of documents. I'm going to show you a graph about NPM libraries and authors and maintainers. So you could restructure it that way as well.
Okay, so composite or synthetic key at that point, right?
Yes.
Okay, yeah, makes sense.
All right, so just some more design foundations, and so hopefully the audience is finding this interesting. I really wanted to talk about the design rather than just doing a quick demo, because I want to make sure I portray the the actual implementation and to show how efficient this design is. So those triples that I mentioned, in addition to letting them all live on the same physical partition, we can leverage Cosmos DB indexing and furthermore composite indexing on those triples or the other document types in your system. So for example, if you needed to query the triples based on multiple factors, you can create composite indexes. And a composite index in Cosmos DB is an index not of one attribute, but on a set of attributes. So if you have a select or a where clause, for example, where attribute A is this and attribute B is that, and attribute C is something else, then you can create a composite index on attributes A, B, and C in that sequence, right? And that's a composite index. And Cosmos DB will execute those queries automatically, efficiently, using those composite indexes.
Makes sense. Yeah, I mean, even like you said, it's going to get even more efficient when you create those composite indexes with multiple properties in there.
Yeah, and I'm sure you've had a previous Cosmos DB Live TV session on composite indexes. So I'm sure readers can find.
Oh yeah, multiples with Tim Sander when he was running our query and indexing engine stuff. There is, folks, go back and check our library for past episodes. plenty of great content there. So, yep.
All right. So I'm going to accelerate a little bit. So furthermore, the triples actually point to the, if you will, the vertices. Right, so the triples in this implementation contain the document ID and partition key of the things that they're pointing to. Thus we can do very, very efficient lookups of those things. One of the killer features of AltGraph is that you can, back to the index, you can read the index, meaning the set of triples into memory, maybe cache that if you wish, and then traverse those triples in memory, right, at thousands of times faster than disk. And again, you can cache those sets of triples, or even the things that they point to. So there's two caching solutions I can recommend. So what I'm going to show is just Azure Redis Cache, which is just our PaaS service around the open source Redis Cache solution, which is really quite good. But we also have Cosmos DB integrated cache. So just imagine a cache sitting in front of Cosmos DB, where alternatively this data could be cached. So what's nice about the integrated cache, of course, is that it's integrated, right? So you don't need a separate solution for caching. It'll just automatically be built into the database.
By the way, that's now GA.
Yes, yeah, this is a great feature.
Here, I'll even real-time banner creation. I'll put up the nice blog entry for it. So go find us on devblogs, Microsoft.com, Cosmos DB. Scroll down almost to the bottom of that first page, and you will see our GA announcement for our integrated cache. So there you go.
Awesome. Thank you. Yeah, that's really a great feature.
Yeah.
I'm not going to talk too much about this because your previous guest has talked extensively about Spring, but I use Spring Boot, Spring Data. Again, Mark, as you indicated, we have a really nice Spring Data SDK for Cosmos DB. There's a link to it. It quote unquote just works. It just works the way you would expect a Spring Data repository to work. And furthermore, you can extend it, time permitting, or at least in the repo. There's examples of how you can extend the base functionality of a Spring Data repository. So hopefully we can touch upon that. Lombok, some people hate it, some people love it. I love it because it eliminates so much low-value code. It just generates or synthesizes code for you. So I won't further discuss that.
Cool.
Yeah, I'm sorry. Did you have a question there?
No, but I am going to show this comment here. Sean Alexander, one of our viewers, love this stuff. So he's just as excited as I am. So I'm definitely can't wait to see the app you built on this thing.
Yeah. So
and the design principles behind this thing and what you did. This is extremely well thought out. I can tell.
Well, I appreciate that. So somewhat humorously, right? So I was listening to iTunes this morning and Pink Floyd, and the song where basically the singer is saying just nod if you can hear me, right? So when you're giving a live presentation like this, it's hard to tell if there's any audience members actually listening. I can't really see who's dialed in. So I'm thrilled that at least one audience member commented.
Well, I'm glad you used that song from Pink Floyd as a reference rather than say dogs. or something like that from the Animals album. So thank you
Yeah,
very much.
yeah, yeah. I've got lots of 70s rock and roll references.
Okay.
Yeah, so I like most of us, I'm on a budget. So I chose to use D3.js as the UI implementation. So D3.js is a really nice open source, full-featured JavaScript framework. This is one example of a visualization you can do of a graph. I know it's extremely small, but I think your viewers can get the idea of it. We also, Microsoft also recommends some other graphic visualization JavaScript libraries. So there's a link here for you. Basically AltGraph is, bring your bring your own UI library, right? So it's agnostic regarding what UI you choose. Again, in the reference implementation, I just use D3.js.
Does it perform well? Curious.
Yeah, it does. It does. It's rather bizarre, though. D3.js actually requires you to provide the UI with two CSV files, right? So there's endpoints in the Spring Boot application here that actually serve up those CSV files based on that. And so, yeah, I'm really surprised that D3 uses CSV as opposed to JSON files, JSON data.
Oh, that's okay. I see. To feed the UI, it reads from
Yeah,
CSV.
yeah. There's a CSV file for vertices and the edges, and then the UI kind of renders them.
Huh. Okay.
Yeah. So the AltGraph implementation is actually version 2 of this graph I did 3 years ago, right? So about 3 years ago, I implemented something with our Cosmos DB Gremlin database. And so what I intentionally chose the same data set, right? So it's a bill of materials graph, back to that topic, Mark. That's very applicable to manufacturing. But it's number one, it's really hard to find manufacturing data, right? And number two, it's really hard to find anything that's understood by customers, by people, right? So for example, Honda cars, I'm sure they have a crazy complex bill of materials, but the names of the parts are rather arcane. So in the Node.js ecosystem, the package management system is called NPM, Node Package Manager, and it has a really nice set of tooling to determine the dependencies of a given library. So I kind of mined NPM, started with a list of maybe 1,000 of my favorite packages, traversed them, got their dependencies, et cetera, and that's why I captured this data set.
That's fascinating. What a great data set to use to do that. Because you're absolutely right. Like it's very, I don't even think you can find like a bogus or a faker library that's going to spit out BOM, a bill of materials data for you. But if you could go to a real data set like NPM or maybe NuGet or Maven or whatever, it's going to have package and dependencies. That's really sweet. Great idea.
Yeah, thank you. All right. So all the previous slides were theory. So now we're getting into the actual implementation. So what's really nice is that with the Cosmos DB SQL API, you can implement this graph solution with a single container, right? You don't need a container for your vertices and your edges or whatever. You can just have a single container, right? So it's quite simple. I typically use PK /PK as a partition key. I also typically use doc type as an attribute in all of my documents to distinguish, just so I can distinguish what each one is. So for example, you might have a triple and you might have an author document in the same container. And so we use the doc type attribute to distinguish those two. This reference implementation also implements the concept of a tenant ID, right? A multi-tenant environment, and also like a line of business, right? So back to, theoretically, Honda and their, when you produce the graph, maybe you don't want to mix in the components for their lawnmowers versus the components for their automobiles, right? So you might want to separate the data into several lines of business and restrict the triple, have the triples indicate what line of business it is, right? So that's how you can efficiently, create a set of triples so that you don't read millions of them into memory. You just read the ones that are pertinent to that particular line of business.
Makes sense. Yeah, if you were like a Honda, I would probably use that so that I'm not reading
Yeah.
lawnmowers and motorcycles into cars and jets.
Yeah, exactly. And we're kind of tongue in cheek talking about Honda, but I'm sure many customers have a similar.
Oh, sure.
They
Yeah,
just want
yeah.
to
No offense, Honda. Sorry, you guys are
Yeah,
great.
exactly. Yeah, so Synapse Link, per that previous slide, that busy slide with the architecture. So enabling Synapse Link is generally a good idea. This implementation does not yet utilize hierarchical partition keys. This is a new feature coming in Cosmos DB. Right now, you define a single partition key attribute, but we're going to have new functionality that allows you to store or to define up to 3 partition keys. So it's a hierarchical partition key. This will be a really nice feature when it gets rolled out.
By the way, just a comment. You do a couple of things that I consider best practices in modeling and design. First is using a generalized property name for partition key gives you the benefit of actually doing in-place partition key migration.
Yes.
So you could read that out into memory, change the value, and then insert it right back into your container, right? Where versus if you hard code that as a I don't know, zip code or some actual some name for actual something, you're then forced to actually change it into another container with another name. So that's one thing. The other is the use of doc type to distinguish entities. This is especially important in a document database, particularly Cosmos, where you can mix entities. And in fact, in many cases, that's a best practice, both from a storage and from a efficiency perspective. The other one that I also consider best practice is adding a version property in there because it allows you to more gently version schema and types in there. And also within your POCOs, inherit from a base type that includes all 3 of those within there. And then allows you to essentially, you can obviously inspect that, deserialize into your base type, inspect any of those things in there. Your doc type, obviously, okay, that's a customer versus an order. I'm going to deserialize an order. Okay, well, which version of order? Okay, well, I'm going to check my version property because I've deserialized that, and then you can deserialize further into another type there. So anyway, this is good. I'm glad you showed that. I wish more people implemented or just use those as a pattern, basically, for designing for Cosmos.
Yeah, I really appreciate you mentioning the version attribute. So I took a note, and I will add that to this reference implementation because I agree that's a great idea.
Yep.
All right. So this is super small, I'm sure, for the reader. But so here is just a sample document. And again, this is like the NPM ecosystem. Node Package Manager, and of course I chose something that I authored. So I wrote this library called TCX.js. So this is just an example what the JSON looks like. And again, I'm sure readers are kind of squinting right now. But the really nice thing about this data from NPM is that it has information about the library, but down here in line 14, it has like a dependencies object, right? So this library TCX.js uses this library called XML to JS. So you can probably get the idea that, this is the raw material for this graph. A component uses this component.
Yeah, cool.
And yeah, so also capturing like there's an author. Yeah, there's an author and maintainers. So those are also going to be interesting for this graph. So, we want to maybe have a graph of, a dependency graph of a given library. But then maybe we want to understand, okay, what other libraries did that author create, right? So that's what this reference app implements.
How do you consume this data? Is there just a REST endpoint you can just call a get for that and pass in like a package name, or can you pass in nothing and get everything? Or I'm just curious how they surface that.
Yeah, good point, so Mark. So this is kind of like I've curated this raw data set from NPM. It exists as I think as a single file in the GitHub repo, and I'm not using Spring Data to load it. I'm using the Cosmos DB native SDK version 4, the bulk loading functionality to actually seed this database. So yeah, this repo is kind of I think it's a fair example of using the bulk loader as well as using Spring Data.
Okay, good. So I guess my question was, how can you get it? And what you're saying is this is sitting as a file on a repo. So I don't have to go over a REST API to like extract one at a time out of there.
No, yeah, this is a pre-curated data set.
Got it.
But
Cool.
In a real world situation, I would imagine that the customer has like a web UI, where somebody wants to create a relationship between two things and create a triple.
Right on. Cool.
All right. All right. So I've been talking about triples for 45 minutes. It's time to actually show one. So this is a triple, right? This is a triple document. So again, back to that slide that showed what a triple was: subject, predicate, object. So I'm borrowing that concept. And so a triple document, so a doc type is triple. And the partition key is like triple 1, 2, 3. So the tenant is 1, 2, 3. Back to that multi-tenancy design. So that's the partition key, and so it has several attributes relating to the subject, one attribute relating to the predicate, and several attributes relating to the object. The object and subject are similar. I'll just mention what they are. So the subject type, in this case, like it's an NPM library. It could have been an author, a maintainer, things of that nature. The subject label in this case was tedious. So there's actually an NPM library called tedious. And also has like the ID and partition key of that document in Cosmos DB. So back to the point reads. So we can efficiently look up that document if we wish based on the contents of the triple, right? So we don't have to do a query on simply tedious. We already have what its coordinates, so we can do a point read very efficiently. Now, what's really interesting, and so this comes straight from a customer engagement, and so in addition to the the RDF like triples, the subject, predicate, object, what if you had the challenge where, gosh, I just want to kind of peek in to that adjacent vertex just for a few attributes that are most pertinent to me. I don't really want the whole document. In this case, I don't want the whole author. Right, I'm sorry. This tedious library is connected to MS SQL, so that's what the triple. But in addition, right, instead we have the ability to have like subject tags or object tags. So, for example, if you wanted to query like the index of the book, so to speak, on the things that are most pertinent to you. So in this system, the author and the maintainer are pretty pertinent. So wouldn't it be nice if you could just do that read straight from the triples? And better yet, what if the triples were in memory or cached so that you actually didn't have to do a disk traversal of the database to find these relationships? Now, of course, you can't put in this implementation, we didn't put the entire sort of library document embedded here. Just a few, excuse me, just a few of the attributes, so that we could, efficiently traverse the graph and kind of peek into those vertices without storing the entire vertex.
That's very cool, and a good optimization, I would say, as well.
Yes.
And this could apply to anything that where, like you say, a customer may want to peek into something else without having to go all the way do another round trip on that. Definitely more highly efficient if you've already got it cached in memory. In there. So that's very smart. I like that.
Yeah.
I think this would add more complexity in a way when you're materializing it right initially, because you would want to, or does this come in the data set that you're talking to?
Yeah. So it comes in a data set that I've curated, in the repo. However, in any graph database, and that's kind of like one of the misunderstood things about graph databases is that, you don't just throw data into the database and expect the relationships to be, automatically determined. It's like, no, you, the customer, have to explicitly define those relationships, right? So likewise in this solution, it's the same, right? You have to create the triples and the subject and object tags that are pertinent to you. Yeah, so the burden is on the customer to actually populate them.
Yep, cool.
All right. So I'll continue. So, all right. So I've talked all about the, database structure. Let just a brief glimmer into the actual code, classes in the implementation. So I've talked about caching. So there's a class called cache.java in the repo. There's a few others. I'm just going to talk about the ones that are bolded, they're the most pertinent. Something bizarrely named triple query struct. So basically that's the index of the book, so to speak. So as you read the triples into memory, you can, they're instantiated as an instance of this class, the structure. You can optionally, serialize that and store it to a cache, either Redis or integrated cache. So that's a key class in the repo. Obviously, this domain has to do with the NPM libraries and also authors and maintainers. It looks like I didn't list them there. For Spring Data fans, there's a class called Library Repository. It's a Spring Data repository. Regarding the extensions to Spring Data, so also there's a triple repository, but there's an interface that it kind of extends the Spring Data implementation, right? So Spring Data repositories have some built-in functionality, but you can, with our SDK, with our Spring Data SDK, you can kind of extend that functionality and use more of our Cosmos DB SQL syntax. So I think in this example, I'm using like the in clause, the SQL in clause in this implementation. And due to the interest of, because of time, I'm not going to dive in here, but readers are invited to take a look at those classes in the repo.
Yeah, got it. So we implement basically the extensibility that's exposed to that, is what you're saying. So
Yeah,
I got it. Yeah, makes sense.
Yep.
Ooh, I see code. Does that mean we're getting closer to?
Yeah, it gets. So we're getting closer. So there's nothing spectacular about this. This is just an example of Spring Data repository. So it extends Cosmos repository, and it has all the usual annotations in Spring component repository. So there's nothing really spectacular here. There's built-in, if you phrase your methods like this, like find by subject label, right? So the magic of Spring Data is that it'll translate that method name into an actual query, right? So find by tenant and subject label, it'll actually translate that method name into an actual query that's querying on tenant and subject label. So that's kind of like some of the magic that's built into Spring.
Kushaga showed that when he was on the show. I was blown away my mind basically when I saw that. I'm like, that's just incredible.
Yeah,
how it does that.
Way back when I did Ruby on Rails web development, and Rails is full of a lot of this automatic generation of code. It synthesizes code at runtime. It's pretty elegant. But anyway, so that's what the repository looks like. We're getting close. We're getting close to showing it. So rhetorically here. So okay, great. We have the triples in memory. Now what, right? So basically have the raw data for a graph in memory in the form of triples. So what we have to do is actually kind of build it into an in-memory graph based on what we're looking for. So again, we have all the triples in memory, but we have to build it into a specific graph based on a query that we're trying to visualize. So there's a class called Graph Builder that builds a graph. And then finally, depending on your choice of a visualization layer, right? So there's a class called D3 CSV Builder, right? So it takes the graph object and it builds those D3 CSV files.
Thank goodness. I was going to ask about that because that sounds really onerous and hairy and annoying. Thank goodness there's a class that you can shove JSON at this thing and it'll spit out this D3 friendly format.
Yeah. So I actually implemented this class in the repo, but good point. I mean, if users want to use D3, right, then I think that code is suitable for their use.
And is this just a stream that's basically CSV inside?
Yeah.
Okay. So
yeah.
All right.
Yes. So what happens is that the user navigates to the web page, hits enter, executes a query, web request to the back end, generates all these things, does a triple query struct, gets it from cache if necessary, builds this in-memory graph, and then builds the D3 files. And so the client does a callback to the web app to fetch these generated CSV files.
Cool.
All
right. You know what? Everybody's still here, so pretty amazing. I think everybody wants to see this demo. Myself included.
All right. So I appreciate everybody's patience and sorry for the long-winded nature. And let me. All right. Oh, I didn't mean to show that yet. All right. So I'm going to terminate my Spring Boot app. So I'm just going to start up the Spring Boot app again. I use Gradle, by the way. I find it much simpler than Maven.
You use what?
There's a Java build tool callle Gradle, Gradle. I use it instead of Maven because I like expressing configuration in code rather than in XML. All right, so the web app is up and running. It's a Spring Boot web app, and it's connected to Cosmos DB in Azure, and likewise Azure Redis Cache in Azure. So again, the web app is running locally on my laptop. Everything else is in Azure. So let's go to the application. So here's just a splash page. I want to explore the NPM graph. All right. So let's say I want to explore the Express library. So that's a fairly common web framework in the Node.js ecosystem. I can specify the depth of the graph. I'm just going to default to 1. And there's some mysterious caching options here that are just for demonstration purposes. I'll show them shortly. Now, I'm going to hit search. I expect this one to take several seconds because my connection is just being established.
Yeah, right.
So there we go. So that took 6.8 seconds. I'm going to execute it again just to see it's faster. There we go. So 2.34 seconds. All right. So here is a graph, rendered from, so what just happened is that, we did this query, went to the web app. Web app actually read the triples, right, for this graph. Like I said, it built that graph object in memory. It created the D3.js CSVs. Those D3 CSVs were served to the web UI, and D3 rendered this graph. So I did not specify where all these nodes appear. D3 just kind of did it automatically for me.
And earlier when you were saying, hey, if I wanted to peek into something, now let's just say I want to hover over one of those nodes, I would see maybe the author or whatever, this other information that you kind of materialized into that row there.
Yeah, so let's good point. So let's do that. So I don't know what QS is, so I'm going to click it. And so what just happened there is that, we did a query to Spring web app, and it did a lookup of that library document. So it didn't actually read the triple. It actually read the library document itself, right? And then it simply got like the description of that library. Mm. So it's a query string parser. So that's what QS is. I did not know that. All right. So that was interesting. So that was Express to a depth of 1, right? So these are the libraries that Express uses. Let's see something interesting. Let's go a level deeper. So let's go with the libraries that those libraries use. So let's go a depth of 2 from Express. Do a search. So that took 2.5 seconds. Now I'm going to scroll in and out. And again, I know the audience is kind of visually challenged here, but you might be able to see that there's like 3 clusters, the D3. So I'm just going to randomly choose this one. So, and you can just kind of use your mouse and expand and scroll the graph. So it looks like it's centered on debug. So Express uses debug, and debug in turn uses these. Now, what's really nice is that, if we want, we can go to a depth of 3 or 4 or 100. It's up to you. Now, all right. So this last query took 2.5 seconds, and that included like reading all the triples in the graph. And there's probably 7,000-ish in this implementation, as I recall. So, for 2.5 seconds to read all those triples and produce this visualization, that's really not too bad. However, so this is kind of a bit of a UI hack just for demonstration that I built into the app. So let's say we want to cache. So for the cache options, I want to use the cache triples, and I want to produce the same graph, right? So I'm going to click search. And so what was the previous, like 2.5 seconds? So now it only took 656 milliseconds to produce the exact same graph with the cached triples, right? So again, the index of the book was cached to Redis, and when web requests came in, we actually read Redis instead of going to the database. So a couple of points here is that it was super fast, right? It was maybe 4 times faster, but furthermore, it did not consume any Cosmos DB RUs, right? It cost 0 RUs. So this is where I'm saying it's, this AltGraph solution is a high speed and low cost solution, right? Because you can serve this data from cached content.
That's cool. And of course, using our integrated cache, same thing, right? Once it's loaded in there, it's a read through cache. So every time you go back to it, it's not going to cost you any RU, and until it actually gets evicted and replaced with something else. And given that we're talking about NPM, I'm guessing that happens quite frequently.
Yeah.
With new versions of stuff, right? It's a huge system with lots of libraries and frequent updates as well. So, but yeah, this is really amazing, and I love the performance. I'm curious how many RU just a query with no caching would cost. Do you just happen to know off the top of your head?
It's low.
Yeah.
It's like in the order like 80 for this one. As I recall. But
like you were saying earlier, this is all single partition. So
yes.
And yeah, okay.
Now, so use the word eviction. So I sense that I'm running out of time and I'm going to get evicted from this presentation. So I'm going to just one more graph thing to display, and then I think we can wrap it up. So again, so this is a simulated bill of material graph with real world a graph of components from NPM. So, but this is showing the relationship between the libraries, right? What if I wanted to show the relationship between a library and the author of the library? So again, it's kind of a, for this demonstration UI, I just select author and search. And there we go. So the Express library is written by this gentleman named TJ Hollowaychuk. And again, this UI is not the prettiest thing I've ever created. But TJ Hollowaychuk is a prolific author in the NPM ecosystem. So it looks like he's produced all of these libraries, right? So you can click and growl. That's notification, so cookie parser. So yeah, he's written quite a bit. So the point here is that you can kind of segue instantly from a graph of like one type, the graph between the libraries, to a different type, which shows the relationship between a library and the author of a library and the related and the adjacent libraries to that author. So this is a pretty generic, general purpose solution. So the concept of triples. I happen to populate my triples with like libraries, authors, maintainers, but customers or users of this design, can populate their triples with, whatever, entities and edges, exist in their system. And
this is pretty fascinating. Yeah, go ahead. Sorry, I didn't mean to interrupt.
Yeah. So with that, I think I've finally concluded, Mark, and I will pass it all back to you.
This is really fascinating. One quick question, could this be generalized? Is this specific, this interface and the queries and how they work? Or could this basically have anything in there and you're just going to query, you're not querying on package name, you're querying on whatever?
Yeah, so a really good question. It'll take a minute to answer that. But so I as a Cosmos DB GBB, right, I work with many customers to implement Cosmos DB solutions. They're, I have to say, each application is a unique unicorn, so to speak. We don't see a lot of design or implementation similarity from one customer application to another. However, right, I see great potential reuse with the concept of triples, right? So this triple class, in this repo, I don't see really any need to alter that. Now, what it points to, the authors, the maintainers, et cetera, that obviously, is an implementation detail for customers. But I think the core design is really quite reusable.
I think you're right. And I'm going to throw up your GitHub repo again here so people can have a moment and take a look at that and download this and play with it. And yeah, you know what? I was telling somebody the other day, like I love our global black belts and our cloud solution architects, of which you've been now both. Because you've worked directly with customers and helped solve their real issues. The things that you guys come out of those engagements with is just super valuable. I mean, the lessons you guys are learning and the things you guys are designing and helping them build solutions to real world challenges is, I mean, that's just pure gold, in my opinion. And so, I want to thank you for coming and sharing what you've got and what you've done here. I think this is just really fascinating, and I hope our viewers find this valuable too. And I hope they come and download and check out what you've built here in this repo.
Yeah. Again, I appreciate the opportunity, Mark, and I appreciate the opportunity to help all of my customers.
Great. Hey. Thank you, Chris. Great having you on. And thank you, everyone, for joining us this week. I hope you enjoyed this week's episode. Next week, I've got another guest on, Paul DiCarlo. He is a cloud developer advocate. So this is a different organization. These guys are all evangelists, like Mark Heckler, who I had on. They're kind of in that similar org. He's going to show us something really cool he built as well using Cosmos. That kind of does basically looks at behavioral patterns around COVID-19 data. So this is a really interesting project these guys used and a very interesting data set. And Cosmos DB is a part of this. And so I hope you come and check us out next week on that. Hey, folks, we got a user group. Come check us out. Sign up on our meetup page right here. We run meetups every month. New guests talking about really cool things that they're building with Cosmos as well. So come and join, see some cool stuff, be a part of the community, Azure Cosmos DB user group. Love to see you there. Episode 59, I think earlier. So come check out our 58 other episodes. Hey, binge watch. The weekend's coming up, and what else are you going to do, right? Summer's over, right? So go and cuddle up with nice bottle of wine, maybe a box of wine, and watch all 58 episodes of Cosmos DB live TV. So, hey, that's it for this week. Chris, thank you so much. Great to have you on. And thank you, everyone, for joining us. We'll see you all next week.
All right. Thank you, everybody. Bye-bye.
Bye-bye.